right, so the lungs are where all the action is taking place, and they're divided into lobes and even further yet, these bronchopulmonary segments. And if you look at the lungs, you can see the trachea serves both lungs. The primary bronchi, I love this diagram here. This really shows the trees the best. This would be the primary bronchi serving each lung. And what do the red ones represent? Secondary bronchi, correct. And they serve each lobe of the lung. So you can see there's 3 on the right, 2 on the left. And then all these little colored tips are the what bronchi again? Tertiary, and they serve each one of these bronchopulmonary segments. And what's the benefit of having all these separate airways and blood supplies? Yeah. If you get cancer in one lobe of the lung, they can do a lobectomy, and you can preserve the function of the remaining part of the lung. Or if one lung collapses, does that mean the other collapses? No, because we look at the membranes around these, the pleural membranes and cavities. How many pleural cavities do we have? 2. How many pleural membranes? Parietal and visceral? 2. So if one lung is not functioning or collapsing, we can still breathe with the other lung. Not very well. I mean, we're going to be struggling if we have a collapsed lung, right? But the other one will function. So this process of ventilation we talked about is just moving of air in and out of the lungs, and this is a process we're going to really examine now, the physiology of how we breathe. So air always moves in everything, diffusion, pressure, whatever, it's always from high to low, right? Everybody agrees with that? No energy required for going high to low, so high to low pressure. So think of your lungs like a bellows. You know what a bellows is? You use it to like put air in, on your fireplace, and you're trying to get your fireplace going. It's kind of an old-fashioned thing. It's like an accordion, same kind of concept, right? When I pull my accordion out to the sides and make it bigger, I'm sucking air in, correct? And one thing I had when I taught science, on a big thing on the side of the wall, said science never sucks. And people might think that was inappropriate. Well, kids did say my class sucked. And I would say science never sucks. And it's true, because it doesn't. We don't suck anything. What we're actually doing is creating low pressure, and air naturally flows from high to low pressure. So your vacuum cleaner at home, when we say it's sucking up the dirt, it's not actually. The vacuum cleaner has a little fan in it that pulls air, blows air out of the inside of the vacuum cleaner, creating lower pressure. And then in the front of the vacuum cleaner, the air outside is higher pressure, and air comes rushing in. And as it rushes in, it pulls debris with it. So it's not sucking. And same thing when you try to suck from a straw. You're not sucking anything from the straw. All you're doing is creating lower pressure by removing the air, and then the liquid in the straw just flows naturally in. So it's not sucking anything. And the same thing when we breathe. The first thing we have to do is create lower pressure. And how do we create lower pressure in the lungs with breathing? Well, we have muscles. So the muscles do the job of creating a low pressure environment. And how they do that is by increasing the volume. And this is called Boyle's Law. Boyle's Law says that if I increase the volume of a container, the pressure of particles in that container, if I don't change the number of particles, is going to decrease. And I use the example of feral cats. You know what feral cats are? Feral, what that means? F-E-R-A-L. If you grew up on a farm or out in the woods, you know what feral cats are. What are they, Amy?
They're wild.
Yeah. Cats that have never been exposed to human interaction are crazy, crazy. And I learned this in Milwaukee. I was a big animal lover. I wanted to be a vet, and my aunt, we were over for 4th of July, and she said, oh, we got some feral kittens in our garage. I'm like, oh, I'll go get them, and I'll pet them, and I'll make them nice and friendly. Oh, my gosh. If they've never had human interaction, they are crazy. So I caught these cats, and I put them in a carrier, and there were 4 of them, and I threw them into the carrier. I mean, I grabbed them with a sheet and then threw them in the carrier, and they were bouncing around in that carrier, like slamming against the walls, jumping up, and just the whole carrier was rocking back and forth. And that's like gas particles in a closed container. They're banging up against the walls. Now, what would happen if I took those same 5 kittens and put them in a really big carrier? Would they bang against the walls as often? No. So that's what pressure is, okay? When you take a container when you put a certain number of gas particles in it and the container is small, the volume is small, pressure is higher because those gas particles are banging against the sides. If I increase the volume, have the same number of particles, they bang against the sides less pressure. Okay, so when I have air particles and I'm bringing in with a normal breath, if the lung capacity, if I increase the size of the lungs, that volume of air that I bring in the amount of air in the lungs is lower pressure. Does that make sense? Because I increase the volume. How do I increase the volume of my lungs? Two muscles are in charge of that in quiet breathing. So this does not count for when you're coughing or when you're taking an inhale on a cigarette or you're yawning. Those are not quiet breathing. In quiet breathing, this happens reflexively. Put this down. And the two muscles involved are where are they? External intercostals right here. So quiet breathing, I would highlight this here. Quiet breathing. We have the external intercostals contract, so that elevates the ribs and moves the sternum up, so we're increasing the size of the chest. And then the diaphragm is the other muscle involved. That contracts and moves what direction? Look at the arrow. Down. So I'm bringing my ribs out, my diaphragm down, increasing the volume. What is that going to do to the pressure in the lungs? What? It's going to lower. Now I've got this air outside, which is, we assume, atmospheric pressure at sea level is 760 millimeters of mercury. So now I've got this air pressure outside, and now I've decreased the pressure by making my lungs larger. Air comes rushing in, high to low. It rushes in. We're not sucking wind, like we say, right? It's just rushing in by natural high to low pressure. Then the nervous system switches off because it's an active process when we inhale. To get any muscle to contract, don't we have to have nervous stimulation to it? Do you remember what part of the brain has the neuron that goes to the respiratory muscles? When we study the different parts of the brain, which one is in charge of breathing? Yeah, the medulla oblongata has neurons that lead to these muscles, stimulates them to contract, so that's an active process, and then they make the rib cage bigger, diaphragm moves down, air rushes in. Then it switches off. And when you turn off nervous stimulation to a muscle, what do muscles do? They relax. So when they relax, what happens to the diaphragm? Goes back up. What happens to the rib cage? Comes back down. What have I done to pressure? I just decreased the volume. What does that do to pressure in there now? Increases it. Now it's high in the lungs compared to the outside. High to low, air flows out. And that's a passive process. So all we have to do is just turn off the nervous system to get us to exhale. But inhaling is the active part. So again, we're changing thoracic volume number one. And to get that to happen requires, these steps. So if we're going to talk about what causes breathing, what you should write down is, we call the inhalation, I'm going to make this bigger. Inhalation, fancy name for it, is inspiration. So so we're going to say, first of all, it's an active process. What makes it active? Requires what? Nervous input from the what part of the brain? Medulla oblongata. And the pons helps switch from inhalation to exhalation. But anyway, so step number one for inspiration, what has to happen? Number one? What do we have to do to get air to flow from high to low pressure? What do we have to do first? Yeah. Muscles contract. What muscles? Diaphragm. Can't type today. Diaphragm. And, yep, external intercostals. Okay, what does that do? Step number two, muscles contract. For inhalation, step number one is muscles contract. Step number two, what happens as a result of those muscles contracting? Volume increases. And when volume increases, what does that cause? Pressure in lungs, which is the alveoli, right, decreases. And when we do that, what happens? Air flows in from high outside air to low pressure in alveoli. Okay? So that's an active process. So for expiration, just about done here. What can we say about it? First of all, it's a passive process. So step number one would be what? Muscles relax. Volume does what? Oops. Oh yeah, decreases. When the muscles relax, we have the diaphragm moving up again, ribs falling inward. Volume decreases. That causes pressure in the lungs increases, and air flows out from high to low. What stops? What stops inhalation and exhalation? When we go, when you're breathing, just quietly think of like that when you're listening to someone sleep. What stops the inhalation, the exhalation? Things flow from high to low until what? Yeah. Yep. So what stops both processes is when pressure in lungs and outside air is equal. So definitely know the difference in what causes inhalation, exhalation, pressure, volume, what happens first, what happens last. Really, really important for understanding respiratory physiology. So I'm going to put this online. So if you know someone who didn't make it to class, you can say, hey, it's online, and have a wonderful